Hello everyone, welcome to this video. In this video I will be showing how we can apply ML algorithm, specifically regression to a real data set, that is Boston housing price prediction using scikit-learn dataset. First we need to import basic libraries, that is import pandas as pd, import numpy as np, and from sklearn import linear model because we are applying the linear model. And just to test accuracy we need to write this from sklearn.model selection import train test split, and the next step is from sklearn we need to import data set, that is from sklearn.datasets import load Boston, and Boston is equal to load Boston because we are loading the data set, that is Boston. And next step we need to write Boston to get the data, and this is our data, actual data, and this is the feature names, and this is the feature name of the data, and these are the target values, which means the answers that predicted house prices. You can see this, and after that let's load everything into the one data frame, that is the data frame x and y. We use bd for pandas data frame, and we pass Boston.data because the actual data in the Boston data. Next columns is equal to Boston dot feature names because we need the data as columns. This is how we can load the data from into the data frame, and we load the target as Boston.target. Now we are done with the loading. Let's describe it, data frame dot describe, and here we get the column, this is data set, and here we has a mean value, which is mean value of the age, which is 68, and standard deviation of age is 28. So all these data could be useful, but not now, not in this case, because this is pretty simple housing price prediction where we are just going to apply regression, and here we are just applying scikit-learn to apply regression. After the next step is how we apply regression, linear model linear regression, and next step is splitting the data into the x train and y train, x test, y test, and here we split the data set into the two parts, and we pass the data frame which we have to split and the test ratio. So our ratio we generally split it in a general format, that is 0.8 and 0.2. so our training data will be 0.8 and test data will be 0.2. Test size will be 0.2, and we need to put the random set as 4, just as seed of random, because you want to shuffle the data, and here we have a train and test because we need to just shuffle the data, so we are putting random set is equal to 4. And next step is to fit the model, that is rig.fit of x train and y train, and we will get like this. and updating weights and everything. After fitting rig dot fit X train and Y train, and next step is to that is rig dot coefficient coef underscore this function. Here we have the weight which are optimal, and these are 13 weights, and one for each coefficient, because this is a linear regression and each coefficient will have one weight, one each weight. Here we have the 13 values which has one weight equally, which has one which will have the one weight. Now we can predict as well. So this is how we can predict it using one variable. A is equal to rig dot predict of X test. So this is prediction house of house prices. This is a prediction of all the house prices. That is here we take the value of first here we take the first value. Now let's compare prediction with the actual values. So this is the prediction value, so this is the prediction, and y underscore test of 0, that is first value. This is the actual value, and this is the prediction value. This is the prediction value. This is the prediction value. This is the prediction value, and this is the actual value. Array of 0 we got as 12. We see here, so here we have our actual value, that is y underscore test of 0. Here is the predicted values. This is all the predicted values. Now let's compare with the predicted values and the actual values. Let's see how our model is overfitted or not. It is slightly overfitted, I think. Let's see. Now taking the values for a of 0, first value we got 12. Here our actual value is 16, and for first we got 26, and is our actual value is 24. There is an error which will change if you manipulate parameters. This is fit into 3 or more times. So actual value is this thing. So the predictions are always near. Like if you want to use the predictions 1, 2, 3, 1, 2, 3, 17, we got this is perfectly 0.1 mistake. 17 point and 17.3 we got it, and next 1, 2, 3, 18 we got, this is 19, and 4 this is we got as 36, and slightly 37, 1. Here y underscore test of 0 is the actual value. So the prediction pretty close. That means our model is pretty good enough. This model is pretty good enough, and but our regression is pretty basic technique. So next, now here we take this is all x, this is actual values, and now here we take mean square error. So our prediction is here. So here we use numpy np our prediction y test. It will give us and square of it, will give us the mean square error, and that means mean square error is 25.4. And as you update the model or as you use a better model, you observe that the mean square error goes down. Yeah, this is our model, and this is, so we learned, we implemented our model, and we trained our model to predict the house prices for the Boston, and the prediction matches pretty well. Here this is a prediction, and yeah, this matches pretty well in the error, and we store the predictions, and we are trying to compare, and we saw it matched and with the better model, and we will get better accuracy. So thank you.